Okay, good day to everyone. Welcome to the week 4 of our MATLAB tutorial. So for this week, we're going to deal with the operations on matrices and other kinds of operations like trigonometric functions and real and complex numbers. So just a summary for this week's discussion, we're going to learn how to create a row and column matrices, and basically, we are just adding a row or a column to our vectors. So now we're going to create a matrix. Okay. Then after that, we're going to deal with transpositions, determinants, and inverse matrix. So if you are aware on, or you do what we call linear algebra. So basically, this is a great tool. MATLAB basically is a matrix laboratory. It's short for that. So basically here we can manipulate matrices, and perhaps if you would be able to apply it to your projects, assignments, homeworks, or whatsoever. And then after that, we're going to deal with trigonometric functions. And then lastly, for the real and complex numbers. So let's start. Okay, so let's first learn, okay, how to create a matrix. So if you would remember on our um, second week, we tried to create a vector or an array or what we call the column and row vector. So if you remember on how to create them, basically a vector is denoted by this symbol, the bracket, and whatever you put inside it with a given space, okay, then you'll be creating your row vector. But for example, if I were to create a column vector, so you know that they are separated by a semicolon, then you were to create your column vector. So how do we create a matrix in MATLAB? Okay, so first let us determine how many rows or columns do we need. So if you were to notice, if you were creating a column vector, the significance of the semicolon means it needs to move down or proceed to the next row. So I think let's try on doing it too. Or I should say that we can combine the concept of doing a row vector and a column vector. So what do I mean by that? So for example, I place these numbers 1, 2, 3. Then on 3, I want it to proceed to the next column or row, sorry. So gagawin ko 4, 5, 6, then 7, 8. So if I were to check C on my workspace, there we go. We have created a matrix. Okay. So let's say, for example, I want to create a matrix consisting of zeros. So I'll just type this zeros, then this is a parenthesis. Okay, so just remember when creating this kind of matrices, just remember that it should always be row by column. So row comma column. So let's say 3 by 3. Okay. So here's an example of creating a matrix using the command 0. So basically, I just created a 0 matrix. So pwede rin sa ones. Okay. So if you were to ask me if I could create a random number, so if you would remember on our lesson, we used randi. Okay. So that's the maximum number, let's say 100. then the size of the matrix. Okay. So there we have created a matrix containing random numbers inside a matrix. Okay, so feel free to try it for yourselves. Then you may pause. Then I'll proceed to our next discussion, the transposition, determinants, and inverse matrices. So let's just use C. Okay, remember this is our values for C: 1, 2, 3, 4, 5, 6, 7, 8, 9. Then I want to transpose. So transposing in MATLAB is quite easy. So it is just denoted by the quotation mark. So let's just use T. Let's just name transpose. Then C, then put the quotation mark. Then there we go. We have transposed the values. So if you know linear algebra, you know what will happen to these numbers. So basically, the numbers in the diagonal will remain the same, like what happened here. Then what will shift are the numbers 2 to 4, then 3 to 7, then 8 to 6. Okay. Then let's try determinants. So how do we get the determinant of a number? Or a matrix. So if you know the equation on creating a matrix or finding the determinant of a matrix in linear algebra, then you can do it. But since this is MATLAB, and MATLAB makes our life easier, most especially in terms of matrix handling. So just use this command. So I'm going to use assign variable d, then det for determinant, then input or place the variable inside the parentheses of what you want to get the determinant. So do this, then we receive this number. So let's try. What if I want to get the determinant of O? Okay, that's 0. Okay. Okay. Lastly, the inverse of a matrix. So if determinant, we use det. Then if we want to get the inverse of a matrix, then just simply use in of C. So there we go. Okay. So what do you mean by this matrix is close to singular? So if you are studying linear algebra, so when trying to solve a system of linear equations, then its coefficient matrix is singular, then it could lead to incorrect answers. Well, I understand that because our numbers are pretty bad, to be honest. So what if let's try using R? So inv R. Okay. So there's no error. So basically what I used here on the numbers 1, 2, 3, 4, 5, 6, 7, and 9, they are badly scaled. Okay. Meaning the coefficient of the matrix is singular. Okay. If we were to look the meaning of singular in linear algebra, okay, this means that the linear combination of the column vectors sums to a zero vector. So if you want to learn, then I suggest you look at singular transformations in matrices in MATLAB. I mean in linear mathematics or on your courses in college or whatsoever. So Let's now proceed to matrix operations. Okay, so yeah, I just want you to learn or take note that there are certain things that you need to know when dealing with or when operating operations, or for example, manipulating matrices in MATLAB. So for example, let's try this. Wait, first let me clear my screen. Okay, say using the same matrix 10, I see, then I add 10. So this is a scalar addition, meaning that I would add 10 to whatever to every row by column, or every cell of my matrix by 10. Okay. Okay. So for example, I did this. So that's C plus 10. What if I try to do this? I'll just use C2. C times C. Can I do matrix multiplication? So what happened is, so from C, okay, if you would look my C, so what happened here is a vector multiplication. So what if I want to do it like I want to multiply my matrix elements with their respective row by column number. So for example, 1, I will multiply it to 1, then 2 to 2, 3 to 3, 4 to 4, 5 to 5, 6, and so on. So from our previous command, this one, I suggest you would place a dot. There we go. So what does the dot represents is that this is an element-wise multiplication rather than matrix multiplication. Okay, so basically using this dot indicates a element-wise, or you can say it's a scalar, but we know that scalar has another meaning, but it's much more wise to call it element-wise. So meaning we are dealing with element by element multiplication or division. So what do I mean by that? You can also do division here. Just add the dot, then there we go. Okay. So we know that 2 divided by 2 is 1. So we have here a 1 by 1. I mean a matrix containing values of ones. Suppose I want to combine, or I want to duplicate my matrix. So here's what you're going to do. Just do this. So what will happen is the matrix of C, which is a 3 by 3, would result to a 6 by 3. I'm sorry, 3 by 6 matrix. Okay. So what if I have a let's say a matrix that has different or unequal sizes. Let's just say we call this 3 by 1, and we try to multiply it to a matrix that has also a different size. So what happened is, if you would notice, I'm sorry. Okay. So if you would notice, what happened here is the column vector here, E, got multiplied to the matrix C. Okay, I suppose I should do this a bit more cleaner. Okay, so I did C5 and E and C. So what MATLAB did here is si 10 to 10, nag-multiply siya dito, and at the same time, dito. So, kumbaga parang nag-apply ka ng multiplication to all while following this numbers. So, sabi ko nga, what if kunwari, hindi na siya like completely not alike siya. For example, this one. So, pwede pa din ba? So that would be E times C. I'm sorry, it should be F. Okay, so mag-error na siya. Kasi kulang na tayo ng isang column or hindi kompleto ang rows natin that would satisfy the dimensions of the other matrix. So once again, I encourage you to learn or study linear algebra for you to be able to determine kung ano ba yung mga pwede at hindi pwede in terms of matrix multiplication and also the following operations. So that's it. So let's move on to trigonometric functions. Okay, so I would just clear this so we can create or proceed to refresh to another lesson. Okay, so basically MATLAB has 12 trigonometric functions from your normal transcendental functions up to the hyperbolic functions. So how do we do that? First, you need to know that MATLAB is using regions. What I meant is, for example, nag-sine 90 ka, you would get a region. So I would suggest that you need to know that what is 90 in region. So you know that is pi over 2. Then you will get 1. Okay. So let's just say cosine pi over 2. Okay, so that is basically 0. Okay, it's just a short expression that would lead to 0. Okay, let's just try tan pi over 2. Okay, I'm sorry, what's happening? Why? I'm sorry. Let me do this again. Sine pi over 2, that is 1. Okay, so you can see your hyperbolic functions right there. You can also do arcsine. So you would get a complex number. So let's just say sine 2 times pi. Okay. Cosine of 0 should be 1. Okay. So just use the commands as follows. For sine, that would be sine. For cosine, that's cosine. Then tangent, that's tangent. Then if you want to get the arcsine, then a sine, a cos, a tan. Then for hyperbolic, sine h, cosine h, tan h. Then for the arc of the hyperbolic, then use a sine h, and a cos h, and a tan h. Okay. So if you want to do that, and for example, let's try including it inside a matrix. Okay. For example, this one, I want to get the the sine of c. Okay, so there we go. Since these are radians, so I would have a radian, I would get the sine of a radian value. Okay, so of course, if you want to get the um, a special function for that, this is in radians, is how do we get the degrees? Okay, so if you want to get the degree, or you want to solve a trigonometric function in degrees, then just add d. So 90, that should be 1. Okay, so I think this would be more accepted, or you're going to use this much more than the other one, radians, since radians is very large, or we are dealing with decimal points right there. So it's much more tedious than using degrees. So tan d90, this should be infinity. Okay, there we go. Okay. The possible error for the pi there earlier, since when we place pi, we just have this 5 significant digits or significant figures. Basically, when we are dealing with circles, since this is trigonometric functions, we are talking about an irrational number, since when you get the circumference or the ratio of the circumference with the diameter of a circle, it should be an irrational number. But here we didn't have an irrational number, rather an rational number. So that was why when we tried to get the cosine pi over 2 earlier, we didn't get a exact value of 0. Okay, perhaps we tried format long, then try to solve this again. Okay, so that's it. So yeah, it won't change, but yeah, that's what I was saying. Dahil pi is here is not irrational, meaning it does not extend to infinity, as suppose its number should be. So limited lang din yung values na makukuha natin when we are solving for radians. So yeah, just add d, okay, cos d, then 90, then you would get the value. Since degrees are not irrational, okay, then you could also get 180. So that should be -1. Okay. Okay. So that it is for our week 4. See you on week 5.